This is a practice test for test 5, so we're going to work through these problems. The first one is asking you to simplify this expression. So you want to factor the top and the bottom and then cancel out or divide out any common factors. So the top factors into x, and then we had to multiply to get 4 and add to get 4. So 2 and 2, same signs, both have to be negative. So that will be that, the numerator's factors. The denominator will factor into x and x. It has to multiply to get 10 and add to get -7. So -5 and -2 will be the denominator. So since we have a common factor of x minus 2, we can cancel those out. So this is x minus 2 over x minus 5. So for f of x, it says to give your answer in the form f of x over g of x. So in this blank you would put x minus 2, and in this blank you would put x minus 5. Number 2, solve the rational equation and discard any extraneous solutions. Show complete work on your worksheet. So what in the world? Why are all these x's here? Okay. I don't exactly know what it's asking for the restrictions, why there's question marks. We can find the restrictions. Since I took this off of Mom, sometimes the choices get a little wonky. But what we want to do is look at each denominator. So first we would factor the last denominator into x minus 3, x plus 3, and you would see that those factors match the factors on the bottom of the other two fractions. So your restrictions are going to be each factor from the denominator set equal to 0. So x cannot be, we have x minus 3 and x plus 3. Those are the only two factors that we have in the denominators. So when we solve, we get x cannot be 3 and x cannot be -3. So those are your restrictions, however you put them in. Then we want to know how many solutions it has, and if it has one or more solutions, you need to type in your solutions. Okay, so to solve this equation, we want to multiply each fraction by the missing piece from the common denominator. So the common denominator always includes each different factor that you see in the denominators after they've all been factored. So we have x minus 3 and x plus 3. The first fraction is missing x plus 3. The second fraction, whoops, I'm sorry, we don't want to multiply by what's missing. I'm thinking of something different. We want to multiply by the entire LCD. So x minus 3, x plus 3 on each fraction or each piece. And then we can cross out what's in common. So in the first fraction, the x minus 3's cancel, and that eliminates that fraction, and we're just left with 1 times x plus 3. So that's the first fraction. The second fraction, x plus 3 cancels with x plus 3, and we have a plus 1 times x minus 3 left. And on the right-hand side, the x plus 3's cancel, the x minus 3's cancel, and we're just left with 10 on the right-hand side. If we distribute a 1, it doesn't change anything, so we get x plus 3 plus x minus 3 is equal to 10. We combine like terms, the 3's are opposites, so those cancel. So we get 2x equals 10. We divide by 2, so x equals 5. So we have one solution, one or more, we have one. And it says to type your equation like an equation, type your answer like an equation, so we would type in x equals 5. Remember to check your restrictions when you get your answer. If we would have gotten x equals 3, and that's one of our restricted values, then we would have to say there's no solution. But since 5 is not restricted, it's okay to use that as a solution. All right, number 3. A vehicle purchased for $27,500 depreciates at a constant rate of 12% each year. Its value after 2 years can be modeled by the equation given, where P is the original value of the vehicle. Determine the number of years that it takes for the vehicle to depreciate to $10,000. All right, so you have the amount at the end of time, whatever time period you're talking about, and you have your P, which is your principal or original amount. So we want to know how long it takes to depreciate for the new value to be $10,000 if the original value was $27,500. So we're putting that in for A and P respectively, and we don't know T. So the goal here is to find T. So first we would divide both sides by 27,500. We would then have to take the natural log of both sides. So if I leave this in fraction form and just do everything in the calculator at the last minute, that's usually easiest. All right, so take the natural log of both sides, which will allow me to bring down the T. So this will be the natural log of 10,000 over 27,500. Oops. Is equal to T times the natural log, I'm running out of room, 0.88. Then I would divide both sides by the natural log of 0.88. So those cancel out and just leave T. And then I would put all of that in my calculator and find the answer. Okay, when I put that all in my calculator and I round to the nearest tenth, I get 7.9 for T, so that means 7.9 years. Number 4, the average production cost per gallon of producing X gallons of gas is modeled by the function given. If the average production cost is $6 per gallon, how many gallons of gas are being produced? All right, so let's see. X, the average production cost per gallon of producing X gallons of gas. Okay, so it's saying the cost is $6 per gallon. So I could plug that in for C. So I would get 6 equals 2.0, which is just 2, plus 5,000 over X, and solve. So minus 2 from both sides. That will give me 4 equals 5,000 over X. Multiply both sides by X. So that would be 4X equals 5,000. Divide by 4. And we get X equals 1250. So how many gallons of gas are being produced? 1,250 gallons. Okay, number 5, solve exactly. So we're not trying to find an estimate. We're going to solve and give the exact answer. So let's see what we get here. So we have the log base 4 of 6x equals the log base 4 of 2. Since we only have one log on each side and the log base 4s match, we can cross those out and rewrite the equation without that. So it's just 6x equals 2. So when we divide by 6, we see that x equals 2 over 6 or 1/3 in lowest terms. So make sure you don't put 0.33 because that would be an estimate. You want to put 1/3. Number 6, solve exactly. Here we only have one log, so we want to rewrite this in exponential form. So remember, you first identify the base. So the base is 15, and then you go across the equal sign. So 15 to the negative second power equals, go back across the equal sign, 6x plus 9. And so now we're going to solve this. So we have 15 to the negative second power. So we could rewrite that as 1 over 15 squared. Okay, 15 squared is 225. So that's 1 over 225 is equal to 6x plus 9. We could then subtract 9 from both sides. So 1 over 225 minus 9. Let's get a fraction. So again, I'm using my calculator to do this for me, but I get 6x equals negative 2024 over 225. And then I'm going to divide this by 6, which is the same as multiplying by 1/6. Again, you can do this all in your calculator. Change it to a fraction. So I got x equals negative 1012 over 675. And that would be the exact answer, not changing to decimals. That's what you would put. Number 7, find the solution of the exponential equation in terms of logarithms or correct to 4 decimal places. Okay, so this one we want to solve for x. The problem is that it's in the exponent and we want to get it down. So we can do that. We have 17 e to the x is equal to 2. So the first thing we would do is get the e to the x by itself. So divide by 17. So e to the x is equal to 2 over 17. And then we could rewrite this in log form. So since it's an e, it's natural log. Base e of 2 over 17 is equal to x. So that would be your answer in log form. And then if you wanted to do 4 decimals, you would just put this in your calculator. And I get negative 2.1401 rounded to the 4th decimal. All right, number 8, solve correct to 2 decimal places. That's weird directions, but you want to solve and then round correctly. So 6 with the exponent of 5x minus 7 is equal to 107. So for this one, we could rewrite in log form. So let's see, we have our base of 6. We would use regular log. Since we don't have an e, we could just use log. So we would have log base 6 of 107 is equal to 5x minus 7. And then we can just solve this. So we would we would add 7 to both sides. So we have log base 6 of 107 plus 7 is equal to 5x. And then we would divide both sides, the entire side, by 5. So we would have x equals this whole thing. So we could put that in our calculator. If your calculator can find the log with a different base, you can go ahead and do that. If it doesn't do that, then you need to use the change of base formula to find it. So change of base formula says that this would be, let me erase this last x equals log of 107 over log of 6. So that's the change of base formula for this. Right? So that's equivalent to that. And then I would add 7 to that, and then I would divide all of that by 5. Okay? So we have log 107 divided by log 6, and then add 7 to that, and then divide by 5. And I'm supposed to be rounding to 2 decimals, and I got 1.92. All right, so 1.92. Okay, solve the equation for number 9. So for this one, it's similar to the previous one. So I would say log base 3. Well, actually, you don't have to do it that way. I could go ahead and do it. I'll set it up. Log base 3 of 81 is equal to 2x minus 5. And I could go ahead and solve the equation the same way I did the previous one. But this one actually I can do differently because my bases, I can make them match. So 81 is 3 to the 4th power, I believe. Yep. So this is 3 to the 2x minus 5 is equal to 3 to the 4th. So that's 3 to the 4th power. Since your bases are the same, you can ignore them and rewrite the equation with exponents only and solve from there. So we would add 5 to both sides, and we would get 2x equals 9 divided by 2. So x is 9/2. Okay. Number 10, find the time required for an investment of $5,000 to grow to $6,900 at an interest rate of 7.5% per year, compounded quarterly. Round your answer to 2 decimal places. Okay, so here is our formula. So our new amount we want to be $6,900. Our original amount was $5,000. Our interest rate is 7.5%. So as a decimal, it's 0.075. It's compounded quarterly. That's 4 times a year. And we want to know the time. So N is 4, T we don't know. Okay, so we got to undo all of this stuff. So we would start by dividing both sides by 5,000. So that would be 6,900 over 5,000 is equal to 1 plus 0.075 over 4 to the 4t. Let's see, 0.075 divided by 4 plus 1. I could go ahead and write that out as a number if I wanted. So 6,900 divided by 5,000 is equal to 1.01875 to the 4t. Okay, so now I want to get that exponent down. So I could take the natural log of both sides or a regular log, it doesn't matter. So this would bring this down in front. So this would be the natural log of 6,900 over 5,000 is equal to 4t times the natural log of 1.01875. So now to get the t by itself, we divide by everything else. So 4 times the natural log of that number. We do it to both sides. 1.01875. Crosses everything out on this side and leaves the t. And so then I just put that in my calculator and see what I get. So the natural log of 6,900 divided by 5,000 divided by 4 times the natural log, 4 times the natural log of 1.01875. And I got 4.33, round your answer to 2 decimal places. So 4.33 is what I got here. Now, here's a hint. So when you're putting this in your calculator, I put parentheses around my entire numerator. For the fraction, then I hit division, so the division symbol, and then I put parentheses around my entire denominator. So if you're not getting the same answer, maybe try that. So try putting parentheses around the entire numerator and parentheses around the entire denominator and see if that helps. And remember not to estimate until the very end. You don't want to have estimates along the way because that throws off your final answer. Okay, number 11. Let's see what we get here. So number 11, use the given rational expression to identify the following. The expression is undefined when, so we don't want the bottom to be 0. So we would say it's undefined when the bottom is equal to 0. So that means W cannot be -4. For number 12, approximate e to the negative third to 4 decimal places. So here you're just using your calculator to do that. So I would get 0.049, so it's 0.04978. So this 8 is going to round this 7 up. So it's going to be 0.0498. And the other one is e to the 4.92 power. That's going to be 137.0026. And there's a 1 after that 6, so the 6 stays a 6. Okay, number 13. Rewrite the following in log form. So we would identify the base. The base is 2. So we would say log base 2 of 2, go across the equal sign, again, equals 1. So that's what it's looking for, just the log form. Same thing for the next one. The base is 10, so we would say log base 10. We don't have to write the 10 because it's understood to be a 10 of x is equal to negative 2. And the final one, our base is e, so when we see e, we should use natural log. So we would say natural log base e. It's understood to be base e, so we don't write it. Of 3 is equal to x. 14, solve for x. So we start with log form. We're going to change to exponential form. So we identify the base. That's 7. So it will be 7 to the 4th power is equal to 2x plus 14. 7 to the 4th is 2401. I would subtract 14 from both sides and get 2387. Divide by 2. And I would get, let's put it in fraction form, 2387 over 2. All right, number 15, simplify. So we want to factor both the numerator and the denominator and cross out any common factors. So in the numerator, we're going to have x and x. It has to multiply to get 8 and add to get 6. So let's try 4 and 2. That will work. And then the denominator is a difference of squares, so it will be x plus 4, x minus 4. The x plus 4s are in common, so we would cross those out. And our simplified version would be x plus 2 over x minus 4. All right, our final question on this practice test. Solve for x if there's more than one solution. Separate the solutions with a comma. So here, this is similar to one we did earlier. We'll go ahead and work through this one as well. We want to factor the last denominator. It almost always factors in our class into the other factors on the other side, and that's the case here. It factors into x minus 2, x minus 4. Once you find that, you're multiplying all the pieces by that. So you're multiplying each fraction by x minus 2, x minus 4. This is the process all the time in our class. Okay, now we're going to cancel out common factors. So in the first fraction, the x minus 2's cancel and leave us the 6 that was originally there, and then we have to multiply that by the x minus 4 that's left. Then we have a plus. The x minus 4's cancel. We take the x that was already there and multiply it by x minus 2 that's left. And then on the other side, both denominators, both factors of the denominator cancel with the factors that we multiplied by. So it just leaves us with equals negative 2x minus 29. We're going to distribute here. So we'll have 6x minus 24 plus x squared minus 2x is equal to negative 2x minus 29. We're going to have a quadratic equation. So let's combine like terms on the left. x squared plus 4x minus 24 equals negative 2x minus 29. We're going to move everything to the same side and set it equal to 0. So when I do that, I get x squared plus 6x plus 5 equals 0. And then hopefully this will factor. If it doesn't factor, you'll have to use the quadratic formula. So it looks like it factors into 5 and 1. So 5 times 1 is 5, 5 plus 1 is 6. So we have x plus 5 equals 0, which means x is negative 5. And x plus 1 equals 0, which means x is negative 1. So I think I have two solutions, but remember you have to check against your restrictions. So here, our restricted values are what would make the denominators 0. So here, that would be a 2, and here, that would be a 4. So your restricted values are 2 and 4. We didn't get those. We got negative 5 and negative 1. So both of those answers are okay. So both of these would be your answer. I hope you find this review helpful. Remember, this is just one practice test. So you should do the practice test several times to see the different questions that you may get. But hopefully this will give you a good a good subsection of the problems that you may see.